everyone. So this video is having to do with the distance formula. Some of you may be familiar with it, some of you may not be. Some of you did the homework already, you weren't supposed to. But what you're going to do is, distance formula is just an equation. And what I want to do is I'm going to show you how that equation is found. Most of you are familiar with Pythagorean theorem. So what I have here is I have a coordinate plane, and I have drawn 2 points and connected them, and I want to find the distance of these 2 points. So I have made a triangle. When you use Pythagorean theorem, you have to have a right triangle. So what we have here is we're going to have the difference in y2 minus the difference in y sub 1. And here we're going to have x sub 2 minus the difference of x sub 1. So we're finding the distance from here to here and the distance from here to here. So it's the difference of them. If you use the Pythagorean theorem, it's a squared plus b squared equals c squared. C squared is always your hypotenuse. So in this case, our d is our hypotenuse. So it's just d squared equals, and then we're going to take our side lengths. X squared, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now, you can't have a d squared here, so we have to get rid of that square root. So in order to get rid of that square root, we're going to take the square root of both sides, and that gives you d equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. This is the distance formula. If you can't remember the distance formula, just think of how it's derived from the Pythagorean theorem, and that will help you. But this is something that you need to memorize. Right now would be a good chance to pause and write it down. So what I'm going to do is I have an example I'm going to work with you, and then there's going to be a problem that you're going to try. And this problem that you're going to try, you're going to bring into class tomorrow. If you have any questions or anything like that, ask, and we're going to check to see if you have the answer done correctly. So for right now, let's try one together. Alright, so what I have here is I want to find SR. It has endpoints where S is -2 and 14 and R is 3, -1. What we want to do is find the distance of SR to the nearest 10. What I suggest to you to do is to label your coordinates. So this is my first X, this is my first Y. This is my second X, this is my second Y. So when I'm using the distance formula, I'm going to use d equals the square root of this x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now what I'm going to do is I'm just going to substitute in these values in each of these places. So when you have x sub 2, it's 3, so you're going to do 3 minus a -2. You're going to square that, plus our y sub 2 is -1 minus 14 squared. Just like order of operations, that please excuse my dear Aunt Sally, you do your parentheses first, then your exponents. So inside your parentheses here, you have 3 minus a -2. A minus and a minus make a positive, so 3 plus 2 is 5, so you get 5 squared. And then right here you have a -1 and a -14. I can change this to a plus and make that a minus, so they're the same signs, you add them. 14 plus 1 is 15, so it's going to be a -15 squared. Now when you square a negative number, it's always going to be positive, but if you put in your calculator a -15 squared, it's going to give you a negative number. Make sure you put in parentheses. So 5 squared is 25, 15 squared is 225. You add them together and you get 250. So in your calculator, you do the square root of 250, and you get approximately 15.8 when you round it to the nearest 10. So the distance of SR is 15.8. Okay? Hopefully that makes sense to you, because now here's the one you're going to try. So try what is BC and round it to the nearest 10, where B is -30, -20, and C is -15, 10. And good luck. I hope you get it. Make sure you use the distance formula. You substitute in the correct numbers into the right spot, and then we'll check it first thing tomorrow. And you'll have a great night.